Hello there. How are you doing? Welcome back to Worldwide Lights, Dark Matter Web. In the 1930s, a Swiss astronomer named Fritz Zwicky noticed that galaxies in a distant cluster were orbiting one another much faster than they should have been given the amount of visible mass they had. He proposed that an unseen substance, which he called dark matter, might be tugging gravitationally on these galaxies. Since then, researchers have confirmed that this mysterious material can be found throughout the cosmos, and that it is 6 times more abundant than the normal matter that makes up ordinary things like stars and people. Yet despite seeing dark matter throughout the universe, scientists are mostly still scratching their heads over it. Here are the 6 biggest unanswered questions about dark matter. What is dark matter? First, and perhaps most perplexingly, researchers remain unsure about what exactly dark matter is. Originally, some scientists conjectured that the missing mass in the universe was made up of small faint stars and black holes, though detailed observations had not turned up nearly enough such objects to account for dark matter's influence, as physicist Don Lincoln of the U.S. Department of Energy's Fermilab previously wrote for Live Science. The current leading contender for dark matter's mantle is a hypothetical particle called a weakly interacting massive particle, or WIMP, which would behave sort of like a neutron, except would be between 10 and 100 times heavier than a proton, as Lincoln wrote. Yet, this conjecture has only led to more questions. For instance, can we detect dark matter? If dark matter is made from WIMPs, they should be all around us, invisible and barely detectable. So why haven't we found any yet? While they wouldn't interact with ordinary matter very much, there is always some slight chance that a dark matter particle could hit a normal particle like a proton or electron as it travels through space. So, researchers have built experiment after experiment to study huge numbers of ordinary particles deep underground, where they are shielded from interfering radiation that could mimic a dark matter particle collision. The problem? After decades of searching, not one of these detectors has made a credible discovery. Earlier this year, the Chinese Pandax experiment reported the latest WIMP non-detection. It seems likely that dark matter particles are much smaller than WIMPs, or lack the properties that would make them easy to study. Physicist Haibo Yu of the University of California, Riverside, told Live Science at the time. Paul explains. Dark matter. Paul Sutter explains what dark matter is and how physicists know the invisible substance exists. Does dark matter consist of more than one particle? Ordinary matter is made up of everyday particles like protons and electrons, as well as a whole zoo of more exotic particles like neutrinos, muons, and pions. So some researchers have wondered if dark matter, which makes up 85% of the matter in the universe, might also be just as complicated. There is no good reason to assume that all the dark matter in the universe is built out of one type of particle. Physicist Andre Katz of Harvard University said to Space.com, Live Science's sister site. Dark protons could combine with dark electrons to form dark atoms, producing configurations as diverse and interesting as those found in the visible world, Katz said. While such proposals have increasingly been imagined in physics labs, figuring out a way to confirm or deny them has so far eluded scientists. Strange quarks and muons, oh my! Nature's tiniest particles dissected. Do dark forces exist? Along with additional particles of dark matter, there is the possibility that dark matter experiences forces analogous to those felt by regular matter. Some researchers have searched for dark photons, which would be like the photons exchanged between normal particles that give rise to the electromagnetic force, except they would be felt only by dark matter particles. Physicists in Italy are gearing up to smash a beam of electrons and their antiparticles, known as positrons, into a diamond, as Live Science previously reported. If dark photons do exist, the electron-positron pairs could annihilate and produce one of the strange force-carrying particles, potentially opening a brand new sector of the universe. Could dark matter be made of accins? As physicists increasingly fall out of love with WIMPs, other dark matter particles are starting to gain favor. One of the leading replacements is a hypothetical particle known as an axion, which would be extremely light, perhaps as little as 10 raised to the 31st power less massive than a proton. Axions are now being searched for in a few experiments. Recent computer simulations have raised the possibility that these axions could form star-like objects, which might produce detectable radiation that would be quite similar to mysterious phenomena known as fast radio bursts, as Live Science previously reported. What's up with the Gamma or Libra results? A long-standing mystery in particle physics are the puzzling results of a European experiment known as Gamma or Libra. This detector, located in an underground mine below the Gran Sasso Mountain in Italy, has been searching for a periodic oscillation in dark matter particles. This oscillation should arise as the Earth moves in its orbit around the Sun, while flying through the galactic stream of dark matter surrounding our solar system, sometimes called the dark matter wind. Since 1997, Dama or Libra has claimed to see exactly this signal, though no other experiment has seen anything like this. So guys, this was all about today's video. Share as much as you can. That really motivates us to create more content for you guys. With this, we end our video. Hope you liked the video.